Greetings to all. This is Vaishnavi, Assistant Professor, IT Department from SNS College of Engineering. Now we are going to see about the paging in operating system. Paging, it is a memory management scheme that permits the physical address space of a process to be non-contiguous. It avoids the considerable problem of fitting the varying size memory chunks on to the backing store. Basic methods. It divides the logical memory into the blocks of same size called the pages. Next one, frames. It divides the physical memory into fixed size blocks. Page size is the power of 2 between the 512 bytes and 16 megabytes. Address translation scheme. Address generated by the CPU, that is logical addresses divided into page number used as an index into a page table which contains the base address of each page in physical memory. Next one is page offset, that is it combined with the base address to define the physical addresses, that is physical address is equal to base address plus offset. Next, here we have the diagrammatic representation for paging model of the logical and the physical memory. First one is paging hardware. Next diagram. Next one, allocation. When the process arrives into the system, its size that is expressed in the pages is examined. Each page of the process needs one frame. Thus, if the process requires n pages, at least is equal to n, that is frames must be available in memory. Next point, if is equal to n frames are available, they are allocated to this arriving process. Next one, the first page of the process is loaded into one of the allocated frames and the frame number is put into the page table. Next one, repeat the above step for the next pages and so on. Next one is a frame table. It is used to determine which frames are allocated, which frames are available and how many total frames are there and so on. That is, it contains all the information about the frames in the physical memory. Here we have the diagrammatic representation for before allocation and the after allocation. Next one is hardware implementation of the page table. This can be done in several ways, that is using page table base register and the translation look aside buffer. The simplest case is the page table base register is an index to point the page table. Second one is translation look aside buffer. It is a fast lookup hardware cache. Next one, it contains the recently or frequently used page table entires. Next one, it has the two parts, that is key and the value, and then it is more expensive. Next one is paging hardware with TLB. When a logical address is generated by the CPU, its page number is presented to TLB. Here we have TLB hit, TLB miss and hit ratio. First one, TLB hit. If the page number is found, its frame number is immediately available and is used to access memory. Next one, TLB miss. If a page number is not in the TLB, a memory reference to the page table must be made. Third one is hit ratio. Percentage of the times that a particular page is found in the TLB. For example, hit ratio is 80% means that the desired page number is in the TLB is 80% of the time. Next one is effective access time. Assume the hit ratio is 80%. If it takes a 20 ns to search TLB and 100 ns to access the memory, then the memory access takes the 120 ns, that is TLB hit. Next point, if we failed to find a page number in the TLB, then we must first access the memory for the page table and then access the desired byte in the memory. That is, therefore total is equal to 20 plus 100 plus 100, that is 220 ns, that is TLP, means the effective access time, EAT is equal to 140 ns. Thank you.